For the circuit, for the amplifier shown, we're asked what is the largest output resistance in k ohms that can be used and still get at least 70% of the amplifier's open circuit output voltage, with it being equal to AvVi to appear across our RL. And we use our RL as 97.8 kilo ohms here. And so the two important parts of this problem are the following. We have the largest output resistance, that's important, and then we also have the 70% of the amplifier's open circuit output voltage. And so what this means is that our output voltage, so our V naught, has to be 70%, so that's basically 70 over 100, equal to our AV VI, and we have our open circuit output voltage, so we know that current is going to flow like here and this way, and it's going to go there. Now we have the R naught and our RL over here. We have the V naught here. Now this V naught is what we're going to want to focus on. So what we're going to have is a voltage divider method, which we've been using quite frequently. So inside of here, our voltage divider, we have the resistor tied with our output voltage. So we're going to have our RL divided by our RL plus the other resistor, which is our R naught right here. And so now we have our equation. We can substitute into our V naught though. So instead of having a V naught, we know that, in fact, this 70% shouldn't even be here, because this should just be our V naught. This should just be the output. I made a mistake there. So this is just V out. Now V out itself, the output is 70%, so 70 over 100, of the amplifier's open circuit output voltage. So when we look in the amplifier, which is right here, the open circuit output voltage is going to be our AV VI. And so that means that these can cancel out. And so we're just going to be left with 70 over 100, and this is going to be equal to our RL over the RL plus our R naught. And so if we plug the values that we have into a calculator, we're going to get this right here. Now we want it in kilo ohms, so we're just going to multiply that by 1 kilo, and so that's going to move the decimal place over. I'll write it out anyways. So it's going to give us 41914.29. So we multiply this, and so this is in ohms, right? Because we were solving for our, not our RL, we're solving for our R naught, sorry, because our R naught is going to be the largest output resistance. Right here, it's the output resistance. And so we're going to have this be equal to our R naught, multiplying by 1 kilo. Oh, I'm sorry, this is 1 kilo over 10 cubed, because that's the conversion. And so we move for decimal place 3 to the left, and we're going to get approximately 41.914. And that is the answer for this problem. Now, if our problem was a little bit different, and we were given like current out front, if we had, this is like the Thevenin equivalent, if we had the Norton equivalent where we have a current here, and then our resistor right here is in parallel with this one, and we have a current flowing through here, well, it would be quite similar. Instead of having the voltage that we were looking at, we would just change it, because it's essentially the same thing. If we're still looking for a percent, this isn't really equal. You can, instead of having an equal sign right here, this should be greater than or equal to, because we're saying what is the largest output resistance can be used and still get at least 70%. So that's how that would work. And if we had some like current across here, and we had current across here, this would be our input current, this would be our current here, our current I, and this is our source current. We would just say that, well, our II here, right, is going to be equal to our I source. It's usually how it is, like how we would have had it right here. We have our V output, which is the current output, equal to the IS, and then we have the resistance. So this current is flowing over our RS. Remember that the current division and the voltage divider, they're opposite of each other. So this one right here, we have the resistance side here. Now if we have the current flowing through this way, it's just looking at this resistor right here. That's why it's the RS and not like the RI. And then we have RS plus RI, and then we would just take the percentage of that. And so that is if we again had a current, but this is the work we would do for this problem. And that is how we would look at this material.